Hi everyone, welcome to Stm32 Hello World Project. In the last tutorial we have done LED blink project by using Stm32 CubeMX or the graphical user interface. However, in this project we won't be using Stm32 CubeMX and we will be building it up from the ground, and we will be displaying some messages by using printf on the screen. Similar to the previous tutorial, we'll go to the file, new Stm32 project. So here we will choose the board. So here again I have to give the name of the project f4 underscore hello underscore world, and we have got the options. I won't be changing the options, but I will be making it from stm32 cube to empty. So this time we will be making an empty project. Then I click on the finish. Now you can see the folders have been created. We have got an include folder, we have gotten a source folder. So this time, because we have made it an empty, so it's not containing all the files, but the important file is the startup file, which is still over there. It is a very important file as it is linked with the microcontroller itself, and you can see this startup file is made up for STM32F407. And another important part in this one is that it's containing the device vector which are linked with the interrupts. Now we go to main.c. This is the template of main.c, and we try to build it without making any changes. And now it's built it successfully. However, we can see one warning is over there. Let's see with the warning. It's complaining about FPU is not initialized. To remove this warning, we have to go to the project, right click on the project properties. Now we go to MCU settings, and in MCU settings we have to turn off the floating points, and we have to make it from hardware to software. Now we click on apply and close, and now we try to build it again, and now we can see it has built it successfully and there are 0 warnings. To display the message on the screen, we will write printf command. So this is the printf command with the hello world, and we will try to build it now. I saved it. Now building it up. Now it has built successfully. However, it's showing me 2 warnings. Let's see the warnings. The warning is incompatible implicit declaration of built-in function printf. Basically the problem is that we have written the printf, but we have not included the library, so it doesn't understand what the printf is. So to include the library, we will write include stdio.h. Now we will save it. Now we will try to build it again. Now we can see that it has built successfully with 0 errors and 0 warnings. So now the question is how and where this message will be displayed. For how, we have to refer to the reference manual and the user manual. So this is the user manual of STM32F4, and if we go to the hardware layout, here we can see the first part of this board is a debug part, which is used for debugging STM32F4 devices. The rest is the microcontroller and its peripherals. Now we refer to the reference manual. In reference manual, if we browse across the index, we have to go to the 38th chapter, which is debug support. In this chapter, you can find out the information that STM32F4 uses 2 interfaces for debug. The first interface is a serial wire and another one is the JTAG. As we are dealing with serial wire interface, so we can see that there are 3 pins which are dealing with debug support. So those 3 pins are SWDIO, trace SWO, and SWCLK. SWCLK and SWIO is used by debug support for communication, and we can see that trace SWO is linked with ITM. ITM is instrumentation trace macro cell. Whenever we are tracing any information, it is written into ITM register and it is provided to the outer world. So for ITM, you can refer to 38.14. For better understanding of working of ITM, you can refer to this chapter. So now we have got a basic understanding of how the information from the microcontroller to the outer world during debug session is sent. We will be using this ITM for displaying printf messages. So now back to Stm32 Cube IDE. Here I will be redefining a low-level function which is used by printf. The low-level function used by printf is _write. This is basically used by GNU library for low-level functions. This _write function has 3 arguments, and you can see there is a function itm _sendcar. So now when we will compile and we will call printf, it will be corresponding to _write. In syscall.c you can see _write function is written, but it is being attributed with weak. So we are redefining it and we are telling it whatever we provide with the pointer, it should be sent to itm send car. So we will try to now compile it. Now it's giving us an error, and the error is that it doesn't know itm _send car function. For this function, we will use a definition from this file. I have created this file and I will be providing it. I have copied the function and the definitions, and I will simply put it over here. Now, if I save it and now try to build it, we can see there are 0 error and 0 warnings. Now, for the curious people, the function and definitions what I copied, what do they do? We will start with itm sendcar. itm sendcar function is used to send the information to itm register. Here we can see the type definition of itm register. And where did I copy it from? You can copy itm _sendcar, and we can go to the search option, search, and we can write itm sendcar over here and we can look for it. So this is the f4 hello world is our project, and we have got the one of the old project which is f4 led blink 1. Here if we go to core cm4.h, the function which is itm sendcar is defined over here. And now if we see itm, it's been defined over here. We look for itm type, and here we can see the register is defined. I have copied these functions and definitions from here to f4 hello world project, because we are not using Stm32 Cube MX, because of which this definition and these functions are not provided. So basically if we use core cm4.h, then we don't have to redefine it, but we have made an empty project, because of which we have to do that. We will run the debug session now. We can see the debug session has started and it's waiting at line number 97. If I run it ahead, it won't be displaying any printf messages on the console screen. To see printf printed messages, we have to go to Windows, Show View, SWV, which is Serial Via Viewer, and then we have to go to SWV ITM Data Console. Now in this data console, we have to first go for the setting. We have to enable 0 port and we have to press OK. Now whenever we want to see printout messages, we have to enable the capture. Now if we press the play button, the message will be shown on the console window. So here you can see hello world. So we will stop the program now. I will cut the printf message and I will put it inside the for loop. Now we have put the printf message in the loop forever function. We will save it now and build. And now we can go to the debug session. You can see it's sitting at line number 101, But before we move ahead, what's important is that to create a breakpoint over here. If we don't do that, then the program is going to crash because it will be printing printf hello world forever on your computer. So because of which the RAM of your computer is going to run out at some point. Now we will go to data console window, and this is already enabled for capturing. Now we click on play button. Hello world message is displayed over here. If you have successfully reached till this point, then congratulations, you are finished with Hello World project. This project was created to make you understand more deeply the hardware and software side of debugging embedded projects. Now from this learning, that is working of printf messages, you can display the debug messages on the screen. We will be using this feature in upcoming lectures. Thank you.